Are we alone in the universe? This is a question that humanity has asked itself since we first gazed at the stars. The observable universe is 92 billion light years across. In this, there are hundreds of billions of galaxies, most of which contain billions of stars. There's an estimated 300 septillion stars out there. Now here we are, in the pale blue dot. This is the only place in the known universe that we know life exists. This is Earth, seen past Saturn. Are we the only life forms in the universe? Well, we don't know. I believe that we will find life out there, and I believe that we will find it soon. But how do we go about finding life? We search for life. There's two ways of doing this. The first way is to search for the little green man flying the UFO, or to find the extraterrestrial rummaging through our garbage. The more realistic way is to search for these little guys. These are archaea, very similar to bacteria, just microorganisms. Searching for microorganisms somewhere else besides our planet. So what is the first step for searching for these creatures? Search for water. Water is comprised of hydrogen and oxygen, and that's important, as I'll show you later. But water is essential for life, at least as we see it on Earth, because of the way that water interacts with other molecules and the way that water helps dissolve molecules. Every creature on Earth needs water to survive. So where do we begin our search? Well, why not our own solar system? Mars, for example. Mars has polar caps, as you can see here. Polar caps mean water. So does life exist on Mars? Probably not. It may, but chances are it doesn't. It could have. As you see here, this is a meteorite found in Antarctica. This is ALH 84001. This rock has been matched and identified to be a Martian rock. You can do the research or the science of that if you want. What I want to focus on is this right here. This is a potential phylogenetic feature. This could have been caused by a microorganism, which means that life could have been on Mars. So where else could we search? Let's go to the Jovian system. Here we have Jupiter, one of its moons, Europa. Europa is covered in ice. And many scientists believe that underneath this ice is a vast ocean of liquid water. So much water that it rivals the amount of water on Earth. And this is a moon, a little bit smaller than our own moon. We can find extremophiles, little archaeas that can survive in extreme temperatures and extreme pressures here. Well, we haven't sent any probes out yet, and we're probably going to be doing that shortly, and hopefully we'll find life, and hopefully it'll prove to be fruitful. If not, where else could we search? Well, if our star hosts planets, could another star host planets? Of course. There's a multitude of stars, as I've shown you. So we do find planets around other stars. We call these exoplanets or extrasolar planets. Planets that do not exist within our solar system but are hosted by another star. Typically what we find, though, are giant planets like Jupiter or bigger, because these are easier to find. They have a gravitational pull that tugs in their star, which makes it easier to indicate where they are, or they move in front of their star, which dims the starlight. Smaller planets don't do that as well. But do we find smaller planets, smaller Earth-like planets, things that won't have such a massive gravitational pull, things that would allow for the molecular structures of life to form? Yes, we do. This is a red dwarf star, about 20 light years away, called Gliese 581. The fourth star from Gliese, or the fourth planet from Gliese 581, is 581G. Now this is an artist's rendition. This is not what it actually looks like. So don't think that there's a world that looks like Earth out there. It could. So we're looking for water. We're looking for a planet that's about the size of Earth, maybe a little bit bigger, something that could sustain life. We find that here. And what's important about this planet is its proximity to its star. It's not too far, and it's not too close. The temperature is just right for liquid water to exist on the surface of this planet. And with liquid water comes for the potential of life. So, if this planet is 20 light years away, how do we know if it has water? If we send a space probe, it would take generations to reach this. And it would take 20 years for it to send a signal back. So how do we know if water exists on this planet? Well, every element releases a certain light signature. This is a light signature for hydrogen. If we look through a crystal, I'm sure you've all seen the Pink Floyd album with the crystal and the light and the fires. That's what they do for elements. Hydrogen has this light signature right here. And hydrogen is important because hydrogen's in water, right? What about oxygen? Well, here's hydrogen. This is what it looks like. And this is what oxygen looks like. Now, if we can look at this planet and we can see the light signature, and we could break that light signature apart, and we see this spectrum, and we see this spectrum, then we know that there's a chance for water to be on this planet because it has hydrogen and oxygen. But there's one more thing. Up here we have carbon. Carbon is the backbone for all life on Earth. If it wasn't for carbon, we would not exist. And carbon is very abundant throughout our universe. And if carbon causes us to exist, if water causes us to exist, if these things are essential for us to exist, and if their properties are universal, if they will not change no matter where they are, it would stand to reason that it would be essential for other life forms to depend on these elements. So what would it mean if we found life? Well, why not Earth 2, the sequel? Here we can have another habitable planet, potentially, another Earth. That'd be great. You know, we can feel better about higher populations. We can be more at ease about what we do to our planet, even though we shouldn't anyway. But we would have another place to potentially live. Now, if we do find life on another planet, that doesn't mean it will be habitable to us. It could still be very dangerous to us. But potentially, it could be a place we live. So what else does it mean? Well, if we find life out there, it means that life is not as rare as we thought it was. And if that's the case, then what would be the chances for life somewhere to have evolved into intelligent creatures? Creatures that are far more intelligent than us. What would keep them from coming down and saying hello? What would keep them from coming down and taking the resources from our planet and having some interstellar war with us? As it stands, there probably is life out there. We have very good reason to believe that there's life out there because a lot of these exoplanets are exhibiting the light patterns that show that they have the chemical compounds and the elements to form life. They're in good proximity to their stars. This shows that this is a habitable place to live. These places could host life. But as it stands, this is the only place we know that hosts life. This is the pale blue dot that we live on. And that's all the more reason for us to take care of it. Thank you.